What's up, guys? Let's get this practice test knocked out here. Number one says log base 125 of 5. Remember, the answer to log is the exponent. It's asking you what power would you raise 125 to give 5? And the answer is 1/3. Cube root, remember, bottom is the root, top is the power. Number two, remember the answer to a log is the exponent. Natural log of 1 over e cubed. Remember, the base for any natural log is e. So e to what power would be 1 over e cubed? Well, e to the -3 because it's been flipped. Number three, use a calculator to evaluate that. Just take your calculator, hit your log button, and then punch in 5 on the square root of 3. And I'm doing that right now. And I'm getting, let's go 4 decimal places, 0.9375. Make sure you get that same answer there. Number four, then move the x around a little bit, but remember, it's that base to that power equals that. So it's going to be x equals 4 cubed. Everybody knows 4 cubed is 64. That's all you got to do on that one. 5, the same pattern. 5 to the 4th equals x. That's weird to have 2 like that. Everybody knows 5 to the 4th is 625. So you got that one. Number 6, x to the 5th power is 32. X to the 5th power is 32. The way you solve that is you take the 5th root of both sides. The 5th root of 32 is 2. You can also do it this way if you wanted to. Because the exponent is 5, you could raise both sides to the 1/5 power, and that exponent would just cancel there. Remember, 1/5 power, bottom is the root, top is the power. Same thing as taking the 5th root. All right, sketch the graph of each. All right, because the base here is bigger than 1, it's going to go up. Also, the asymptote, remember when we did exponential, the asymptote was the x-axis. With log, the asymptote is the y-axis. And with exponents, we would always go 1 up for our first point. Here we're going to go 1 to the right, because if I plug in 1 for the x right there, 4 to what power is 1? 4 to the 0 power is. Now, the second thing I'm going to plug in is always whatever the base is. I'm going to plug in a 4 right there, because log 4, base 4 of 4 is 1. So I'm going to go to 4 of 1. There's my second point. Make sure I can see your 2 points there. Connect the dots, la, la, la. And there you have it. Number 8, same thing, except it's been shifted up 2. It's actually the exact same graph. I didn't notice that I put the same base shifted up 2. So I'm just going to take both those points, shift them up 2, 4, 1, just like that. Asymptote is still no left or right shift, so the asymptote is still there. It's just been shifted up a little bit, so it's going to look like that right there. And also, all you can do, if they happen not to be the same base in your test tomorrow, do it the same way. Get your first 2 points and then shift them both up 2 or up whatever, or down whatever the case may be. Number 9, find the domain. Remember, logs must be positive no matter what. So take whatever they give you after the log, the x minus 5. That must be greater than 0. So that means x must be greater than 5. That's your domain. So we can write the domain 5 to infinity. It cannot actually equal 5 because you can't have a 0 there. 10, there's no way to raise 10 to any power and get 0. So it must be greater than 0. Number 10, evaluate this one. Now, use your laws here. First thing I see is I see the first 2 are subtracted, which means I can combine those using division. So I'm going to do log of 10/18 minus log base 350. Now, 10/18 does reduce down to 50 over 9. And because this is a minus sign here, that's also going to be division. So I'm going to divide that by 50 to make it 1 log. If you divide by 50, it's the same thing as multiplying. Keep, change, flip. Multiply by 1 over 50. 50's cancel. Gives me log base 3 of 1/9. And what power do you raise 3 to get 1/9? Obviously -2. The 2 to get the 9, the negative flips it to make it 1/9. So the value of that whole thing right there is -2. Number 11, use the laws of logs to expand the expression. Okay, all I see here is a bunch of multiplication. So I'm going to break it up like log base 2x plus log base 2xz. Now, because there's a square root, remember square root you can write that as an exponential because bottom is the root, top is the power. So I can say log base 2x plus 1/2 log base 2xz. Now, they also don't want you to keep the x and z combined, because they want you to expand it as much as you possibly can, which kind of sounds crazy, but that's what they want you to do. So to finish up, I'm going to say log base 2x plus 1/2 log base 2x plus 1/2 log base 2y. And that's about as far as you can expand that thing right there. Yeah, let's just leave it there. Number 12. Let's try this one over here. So it's got a lot of stuff going on in it. So first thing I see on my numerator, see two numbers multiplied together, so you can split those up with addition, log base x plus log base y. Then I have this in my denominator, which is log. I'm putting a minus because it's what the division is. Remember, the minus sign means division. And because that's a fourth root, I can break that up by putting, fourth root is really 1/4 power. So I'm going to put the 1/4 in the front here because bottom is the root. I've said that a lot in this video. Bottom is the root, top is power. Now, you can't split up addition. Remember, so that's your final answer right here. You can split up multiplication using addition. You can split up division using subtraction, but you cannot split up addition and subtraction. Kind of stuck there. Okay, and then number 13, 14 is the same thing as that backwards. All right, so let's start here. Let's start with the exponents first. That 3 in the front of that second ln makes that x cubed. The 2 in front of this ln makes it x squared minus 3 squared. And now it's all addition. And because it's all addition, I'm going to make up one log, except everything's going to be multiplied. So I'm going to say 4x cubed, x squared minus 3 squared. All that is that one log. If you want to put it all like one big parentheses, that's okay. You don't really have to. But it kind of does show that it's one log there. Number 14, same kind of deal. First thing I see is the first two are added. That means multiplication, and they're conjugates. So I'm going to do a squared minus b. That's a terrible b squared. Let me fix that real quick. B squared, and I have minus, let me do the exponent here, minus natural log c squared. Because it's a minus sign, that means division. So to make one natural log, I'm going to put the a squared minus b squared over c squared. Because the minus sign means division. There you go. Made a bunch of logs into one log. Number 15, use a change of base formula and evaluate, use a calculator to evaluate. So basically you do log of the big number over log 4. If you don't like log, you could also do natural log 9 over natural log 4. It'll give you the exact same answer. Let me punch that in real quick. All right, when I punch that in, I'm getting 1.5850. Please don't forget when you punch it in, you need to close the parentheses around your numbers. If you don't, very good chance you might get the wrong thing there. Okay, two more. No, sorry about that. I thought there was. Now with the review part, $15,000 was invested at an interest rate of 4% compounded monthly. So it's not PERT. Find the value after 7 years. So I'm going to say the final amount is the principal times 1 plus the rate, which is 0.04, divided by 12 for monthly. Now, the exponent's n times t. So I'm going to do 12 times 7, make that 84. Make sure you get that. Now I'm going to punch that in. When I punch it in, I'm getting $19,837.71. Make sure you get exactly the same thing. The only thing that scares me is make sure you're careful with that exponent, that 84. All right, number 17. Graph and label all asymptotes, intercepts, domain and range, all that stuff. Factor first. It's been a while since we've done this. Take a 4 out of the top. That gives x minus 1. My denominator is x plus 2. So here we go. Vertical asymptote, whatever makes the bottom 0, which is -2. Horizontal, 3 rules. This time, the degrees are the same, so you do leading over leading, so I'm getting y equals 4. Vertical, x-intercepts. X-intercepts, whatever makes your numerator 0, which is 1. The y-intercept, cover up your x's, you get -4/2, which is -2. So I'm going to graph all that. Let's see. The vertical asymptotes at -2. Horizontal asymptotes, y equals 4. X-intercept is 1, that's right there. Y-intercept is -2, that's down there. Now, because I know where those intercepts are, I know that part of the curve is doing this for sure. What I don't know is what's going on the left-hand side, so I'm going to take my calculator, plug it in, see what's going on over there. And when I do that, I see the curve is up here, which is good enough for us. Now, domain. Remember, domain is how far left and right it's going. It's going left and right forever, except for it skips the the vertical asymptote, which is -2. The range is how far up and down it's going. It's going up and down forever, except it skips the horizontal asymptote, which is at 4. So there's your domain and range. 2 more. Number 18, find a polynomial with integer coefficients that has degree 3 and 0 is -2 and 2 plus I. Remember, if it has 2 plus I, that means 2 minus I is 1 also. the negative 2. I should do this. The negative 2 came from x plus 2. The 2 plus I came from x minus 2 plus I. And the 2 minus I came from x minus 2 minus I. All right, so if I do that, I get x plus 2. I'm going to work out these minus signs in here, which is going to be x minus 2 minus I, x minus 2 plus I. Now, if you look at, I'm still going to leave this x plus 2 sitting out here, but if you look at these second two parentheses, they're conjugates. They both have x minus 2, and then they have a minus sign and plus sign. So I'm going to do fluid right here. So if I do first, I'm going to do x minus 2 times x minus 2. That's x minus 2 squared. If I do the i's, I'm going to do negative I squared. And that's what I have. Still have the x plus 2 out here. Let's work this thing out. I'm going to go square, multiply together, double. Now square, when I square the negative 2, I'm going to get a 4. But a minus I squared, remember I squared is really negative 1. So 4 minus negative 1 is 5. And then I'm just going to distribute this stuff. I'm going to take the x all the way through, which is going to be x cubed minus 4x squared plus 5x. Take the 2 through, which is going to be 2x squared minus 8x plus 10. And then just combine everything that you can. So I'm going to get x cubed minus 2x squared minus 3x plus 10. And there you have it. That's probably the most work on the whole test. Given this, find all the zeros and real and complex, and then factor. Don't forget to do part B. So what I'm going to do in this one is I'm going to factor it. Because the first exponent is twice as big, I'm going to factor it like this: x squared minus 2, x squared plus 1. Now, I'll give you a couple hints here. When we did this a few weeks ago, I gave you some things you could do. The first one is really a difference of squares. Even though 2 doesn't have a square root, it actually does have a square root. You can write it like this: x plus square root of 2, x minus square root of 2. I also said you can now factor sum of squares by doing imaginary. So x plus I, x minus I, because of square root of them. And if you're not sure about that, you can take those over to the side, solve them, and you get plus or minus I. So that's where those come from. So that's actually the answer to part B right there. Didn't mean to do it that way, but that's the answer to part B. Part A says find the zeros. The zeros would be plus or minus square root of 2 and plus or minus I. Okay, what makes it 0? All right, pretty good little test right there. Contact me if you need any help. I will help you as much as I can. I'll be at school tomorrow early and often, as always. So come see me. Love to see you. Do great. See you tomorrow.